Hello, coming to the next theory part of geometry, that is, we were discussing in the earlier session about the important geometric centers, and we have discussed circumcenter earlier itself. Now coming to incenter, we will discuss about incenter. So what is basically incenter? Incenter is nothing but the point of intersection of angular bisectors to the angle. That is, point of intersection of angular bisectors is nothing but incenter. So in a given triangle, so let this be the triangle with vertices as A, B, C. So now incenter is nothing but the point of intersection of angular bisectors, right? Angular bisectors to this particular vertex will be this will be the one angular bisector, and the second angular bisector for this will be this one, and similarly the third angular bisector for this particular vertex C will be these will be the three angular bisectors. So, and these three angular bisectors meet at a point called incenter, right? So incenter will be represented with the letter I. So incenter will be represented with letter I, and these three will be the angular bisectors, right? And this incenter, that is the point in I, is equidistant from all the three sides. That is, I, the distance between I to AB, I to AC, I to BC will be same. That is the perpendicular distance, right? The perpendicular distance. So the perpendicular would be the perpendicular from this vertex I to BC would be like this, right? Let this be the D be the point here, D be the point, and D be the perpendicular from incenter I to side BC. So ID will be the, what you can say, equidistance. That is, the length ID will be equal to that of, if I draw a perpendicular from I to side AB and from I to side AC. So all these three perpendicular distances will be same, and ID will be equal to, if you draw here also, a particular point will be this will be the perpendicular. So this will be the perpendicular, and from this particular point I, BD, E, F, right? Let us denote like that. So ID will be equal to IE will be equal to IF, right? All those three distances are equal, and all those are nothing but in radius, represented by R. So that particular distance will be represented by R. So IE and ID, IF are equal in length, and their value is nothing but in radius, R. So here one more thing we have to note is, though A and I, so that is AI, BI, CI are angular bisectors, but they are not perpendicular. That is, in all cases they may not be perpendicular to this side. So here if AI is extended to BC, then it will be somewhere around this particular point, not on D. So ID is different from AI. So AI and if we take it as this point EFG, so AIG will be angular bisector, but ID will be the perpendicular from the in center. That we have to keep into mind. That is, the angular bisector need not be the perpendicular. So only we have drawn separately. The line with dotted line with dots is the perpendicular, and the straight line as the angular bisector. So with this radius, in radius, since the distance is same from the in center to all the sides, the triangle with this particular length as radius, we can draw an in circle. That is, with this one we can draw an in circle, right? So don't worry about the circle. So this will be the form of in circle. So IE, ID, IF are the radiuses, that is in radiuses in the given circle. Now coming to relation between angles, that is angle BIC and so on. So in a particular in circle and in a which is inscribed in a triangle, the relation between angles will be like this. Angle BIC will be equal to that of 90 plus half that of the other side angle. That is, since you are calculating from BIC vertices, so the angle will be 90 plus A by 2. That is, A will be opposite one and half that one. Similarly, CIA will be equal to 90 plus B by 2. AIB will be equal to 90 plus C by 2. So this is what you can say, these are the relation between the angle made at in center by the vertices and the other angle also. These three relations are very important because questions will be asked directly from these three formulas. Derivations no need, because it will be not useful for also, because since this BI and CI are angular bisectors, this value will be B by 2 and this will be C by 2. Just for your sake I am saying B by 2, C by 2. So this will be some, let us say, angle BIC. So angle BIC plus B by 2 plus C by 2, they form a particular triangle. So sum of these three angles in a triangle will be 180 degrees, right? So angle BIC plus B by 2 plus C by 2 equal to 180. This implies angle BIC equal to 180 minus B plus C by 2. So this is nothing but 180 minus 90 minus A by 2, sorry, 90 plus A by 2 it will become, so it will be nothing but 90 plus A by 2. So this is the derivation part for how we are getting the angle of BIC. Similarly, it will be the same for angle CIA and angle AIB also, right? Coming to next one, that is coming to next geometric center, that is X center. X center is formed by what you can say, a point of intersection of one in angle bisector, internal angle bisector, and two other external angle bisectors. That is, if we take a triangle, so this is the triangle and the angular bisector for this triangle will be like this, and similarly if we extend the sides, So if we extend these sides, it would be like this, right? So external angles of other two angles, ABC, internal angle bisector of one particular angle and external bisector for these other two angles. So this will be the, what you can say, this will be the one external angle bisector and this will be the another external angle bisector. This is the internal angle bisector. So the meeting point, that is the point of intersection of these three bisectors, will be nothing but called as X center. Similarly, coming to orthocenter. So what is meant by orthocenter? Orthocenter is nothing but point of intersection of three altitudes in a given triangle. Three altitudes intersect at a point called orthocenter. Okay. So one more thing here, altitude we should not confuse with perpendicular bisector. Though it is altitude, though it is 90 degrees, it may or may not divide the other side into two equal halves. Okay. So drawing the triangle. So this be the triangle ABC. So the altitudes for this particular triangle will be so this is the altitude for from vertex A to side BC, and similarly this will be the altitude from vertex B to side AC, and this will be the vertex from side C to AB. So though they are, we can say that though the altitude is perpendicular, it may or may not be what you can say bisecting the other two sides. So other side into two halves, that is, though AD is altitude here, that is making 90 degrees angle, but it is not bisecting the side BC. Similarly EF, though they are also altitudes, they are also not bisecting the other two sides. This should be kept in mind. You should not confuse with altitude and perpendicular bisector, right? The point of intersection of these three altitudes is nothing but orthocenter represented by O. Okay. Similarly, coming to centroid. Centroid is nothing but meeting, that is a point of intersection of medians is nothing but represented by centroid. Median is nothing but the side which the length or the line which is dividing the other side into two equal halves. So this will be the this, let us assume this as a triangle. So the, what you can say, the medians. So this is one median for us, and this will be the second median, and this will be the third median. So let us name the vertices as vertex A, vertex B, vertex C. So the point of intersection of medians is nothing but centroid represented by letter G. So BD is AD is one median, B is one median, CF is one median. So they are dividing the other side into two equal halves. So we should not confuse that, since it is dividing the other side into two equal halves, it may be perpendicular also. It may be perpendicular, but in all cases it will not be. Only in case of equilateral triangle all will be the same. In the rest of the triangles they will be different. Here AD, BE, CF, though they are dividing the other side into two equal halves, but they are not perpendicular to the sides, respective sides, right? And we have one more relation with respect to centroid, that is, centroid is denoted by letter G, right? This centroid will divide the median in the ratio of 2:1, that is two sides towards the vertex and one side that is one part towards the base. That is, since AD is one median here, right, G is centroid, and this centroid will divide the median into 2:1 ratio, two parts being towards vertex. So two parts being vertex means towards A and one part being towards base, right. Similarly, this here B is also one median, the centroid G is dividing the ratio 2:1, and here similarly CF in the ratio of 2:1. So median G divides the median in the ratio of 2:1. This is very important, what you can say, representation for medians. Similarly, coming to important points regarding geometric centers. Important points regarding geometric centers. What are the basic important points for circumcenter? For circumcenter, in acute triangle, the circumcenter will be lying inside. Circumcenter represented by letter S lies inside, and in obtuse triangle S lies outside, and in right angle triangle S will be lying on the midpoint of hypotenuse. This is very important one. That is, in right angle triangle, the circumcenter will be lying on the midpoint of hypotenuse. So if this is what you can say, so this be the right angle triangle ABC with right angle at vertex B, then this particular point, right, this particular point will be S, that is represented with circumcenter, and it will be dividing the hypotenuse into two equal halves, that is nothing but lying on midpoint of hypotenuse, right. So this will be the circumcircle, and S will be the center of circle, that is circumcenter, and BS is the radius, and AS also radius, SC is also radius. BS equal to AS equal to CS equal to circumradius R, represented, circumradius usually represented with capital letter R. So this is, so in a right angle triangle, circumcenter will be lying on the midpoint of hypotenuse, right. Coming to next, in orthocenter. For orthocenter also, acute triangle orthocenter, right. Oh, for acute triangle it is lying inside, and for obtuse it lies outside, whereas for right angle triangle orthocenter lies on the vertex containing right angle, that is, if this be the right angle, so this be the right angle triangle containing at vertex B, then orthocenter O is lying at this particular point. So orthocenter in a right angle triangle lies at the vertex containing 90 degrees. So in a right angle triangle, orthocenter lies at this particular point containing 90 degrees. So that is also one important one. Some direct theory related bits are also asked in the examination, so we should be, what we can say, well informed regarding theory also. So now let us check, after geometric centers, what you can say, these important geometric centers. Now let us go for triangles, important points regarding triangles. For a right angle triangle, let us first see. For a right triangle, so right triangle is represented like this with one line. So second line, so the vertices are A, B, C, and B containing the, what you can say, right angle, right? Now this point will be, this vertex B will also be the orthocenter in right angle triangle, because orthocenter lies at the vertex of right angle triangle, and this midpoint of hypotenuse will be nothing but circumcenter. That is, we know that circumcenter lies on the midpoint of hypotenuse. So S is the midpoint of hypotenuse AC. So this circumcenter will be dividing the hypotenuse into two equal parts. So the lengths BS, AS, SC are equal, and S is at midpoint, orthocenter is at vertex B. And now we can also say that this BS is also median, right? Median to AC, because since BS is dividing the hypotenuse into two equal halves, then we can say that BS is also median, because if a line is dividing the side into two equal halves, then we can say that particular side as median, right? So BS is median to AC, BS is also equal to AS is also equal to SC is also equal to circumradius, because circumcenter is lying here. So but BS need not be perpendicular here, that should be kept in mind. BS need not be, or else will not be, you can write, because it is a right angle triangle, right? So instead of need not be, you can write, you can say that BS will not be the perpendicular from B. So BS will not be the perpendicular, though it is median, though it is circumradius, but it will not be the what you can say, perpendicular to the side AC, right? These are the important what you can say, conclusions for a given right angle triangle. Whereas coming to isosceles triangle, for isosceles triangle, all the centroid and all those things, centroid, orthocenter, circumcenter, incenter, all lie on the same line, This is important. Suppose if this is a triangle and if this is a particular line, so all these what you can say, circumcenter, orthocenter, incenter, centroid will be lying somewhere on the line depending upon the given positions. So it will be lying on same line, but they will not be coinciding to each other. Whereas coming to equilateral triangle, all the circumcenter, orthocenter, incenter, centroid, all those will be coinciding, all are coinciding at one point only. So all these centers will be located at one particular position only. That is, if this be the triangle, so if we notate this particular point as, in equilateral triangle, this will be the S, this will be the O, this will be the G, this will be the incenter. All those circumcenters and all those centers will be geometric centers, what we can say together. All those geometric centers will be located at one particular point only, right? So now we will establish some relation in an equilateral triangle. So this is, let this be the equilateral triangle with vertices A, B, C. So Let us say this will be the perpendicular from A vertex A. So AD. So in equilateral triangle all will be lying at one particular point. So let us be the centroid or orthocenter, circumcenter, incenter all will be located here only. And we know that centroid divides the median in the ratio of 2:1. 2 parts being towards vertex and 1 part being towards the base, right? And since this is also the circumcenter, this AG will be circumradius, right? AG will be circumradius and GD will be in radius in a given equilateral triangle. So in a given equilateral triangle, G divides the median AD in the ratio of 2:1 and AG will be circumradius and GD will be the in radius for us. So based upon the lengths AG and GD, we can draw two circles, that is one is circumcircle and one will be in circle. So we get the relation as AG is to GD is nothing but 2:1, that is centroid will be dividing in the ratio of 2:1. We also know that AG is circumradius and GD is in radius, so it will also be in the ratio of 2:1. So in an equilateral triangle, the ratio of circumradius to that of in radius will be nothing but 2:1. So similarly, the side of equilateral triangle is nothing but root 3/2a, a particular. So let A be the, what we can say, equal length of side. So this will be the side of equilateral triangle, and this is nothing but height of the equilateral triangle, right? This is height or altitude in an equilateral triangle. In an equilateral triangle, height or altitude is nothing but represented by root 3/2a. Here height or altitude is nothing but, in this figure it is nothing but the same, median only will be the altitude and median it will be the perpendicular bisector and everything. So the length AD is given will be nothing but root 3/2a, and we know that, what you can say from this relation, A is equal to root 3/2a, and we can say that the length AG in terms of AD. So length AG is nothing but it will be 2/3 that of AD, because AD is divided into 3 parts, 2 parts and 1 part. So this particular length will be 2 times to that of AD, that is AG will be 2/3 times that of AD. And we also know that AD is nothing but root 3/2a. So AG is nothing but also the circumradius. So the relation will be R equal to A by root 3 will be getting. Between, in an equilateral triangle, the relation between side and circumradius is like this. Similarly, we will get GD equal to 1/3 AD from the incenter, that is in radius. So GD is nothing but in radius equal to 1/3 into AD is nothing but total length, that is root 3/2a. So from this we will be getting the relation as R equal to 1/2 root 3a, that is A by 2 root 3. That is, for circumradius and side of equilateral triangle, the relation is R equal to A by root 3, and for in radius and side of equilateral triangle, it is relation is R equal to A by 2 root 3. Okay. Coming to next important thing is median divides the triangle into 2 equal halves. Not only the respective side onto which it is drawn, but also the triangle also, median divides the triangle itself into two equal halves with respect to area. That is, with respect to area, the median will be dividing the triangle into two equal halves. That is, if this be the triangle and if this be the median ABC, so area of triangle usually represented with the letter delta. We can say that delta A BD equal to delta ADC, since BD equal to DC. That is, we can say that a median divides the triangle into two halves with respect to in terms of area also. That is, ABD equal to ADC, and individually ABD equal to half that of ABC, delta ABC. So these two relations are important. Similarly, coming to let this be the triangle. So this is the incenter in an equilateral triangle, and this will be the circumradius, this will be circumradius, this will be the circumradius, right? A, B, C and G, right? This will be the circumradius. So these circumradiuses of three vertices, when they join together, they divide the triangle into three equal halves. That is, triangle ABG equal to triangle delta area of triangle ABG equal to area of triangle AGC equal to delta of BGC equal to 1/3 of triangle ABC. This is important. That is, this is delta by 3, this is delta by 3, and this is delta by 3. Similarly, coming to what you can say in radiuses also. That is, if we draw a triangle, equilateral triangle ABC within centroid here, and in radiuses will be, this one will be the in radius, this one will be the in radius, and this one will be the in radius with respectively DEF. So the area of these three triangles are also equal, and they are also equal to 1/3 to that of the parent triangle ABC. So this also will be equal to delta by 3, delta by 3, delta by 3. That is, these portions will be in the form of, area of these portions will be nothing but 1/3 that of triangle, area of triangle ABC, right? Coming to when, what you can say, three medians are drawn completely together. That is, this is triangle ABC, okay, right? These are the medians A, B, C, D, E, F. If these are the medians, then these three medians divide this particular triangle into 6 equal halves, into 6 equal halves, 6 equal parts, not halves, 6 equal parts. That is, each part will be equal to delta by 6, delta by 6. So each part will be equal to what you can say, delta by 6, and delta is nothing but area of triangle ABC, right? So similarly, one more thing we have to keep in mind is, if for an equilateral triangle, if we join the midpoints of the sides, so if this is equilateral triangle ABC and these are the midpoints, right? D, E, F are midpoints of sides AB, AC and AB. Then by joining these three midpoints we can form one triangle, and that area of that triangle will be equal to 1/4 delta DEF equal to 1/4 that of ABC. So we can write it as delta by 4, and rest of the parts are also equal, right? So this DEF is also equal to angle AFE is equal to angle, sorry, not angle, delta DEC is equal to delta AFD, right? And each and every part will be equal to 1 by 4th that of area of the parent triangle. So we have to keep in mind all these relations, and all these relations are valid only for equilateral triangle, right? This is important. So here we have seen for equilateral triangle, this is important. For equilateral triangle only we are discussing all these cases, that is the case of all the points geometric centers being coinciding, and the relation between circumradius and what you can say side of equilateral triangle, in radius and side of triangle, and similarly areas of triangles, that is median dividing into two halves, and circumcenter and incenter dividing, and all the three medians dividing into 6 equal parts. And if we join the midpoints of the sides, midpoints of the sides, then also it will be forming one triangle, and this will be dividing into the 1/4 of the total area. So all these cases are for the equilateral triangle. This is very important, we should not forget, right? The questions will be asked directly. It will be given like in an equilateral triangle, by joining the midpoints of the sides, a triangle will be found. What will be the area of the triangle? Given, it will be given the area of triangle ABC as some 40. So area we can say directly 1 by 4th of 40, that is 10. Similarly, how many equal triangles it will, the medians will be found. The medians will form in a equilateral triangle. So all the three medians after intersecting they form 6 equal triangles. Like that, the relations, these relations are very important. So direct bits will be asked based upon these relations also. Okay, thank you.